Yes, students, welcome to the chemistry class, and this is the seventh lecture. I think you are well familiar with the word decay or disintegration. That is, in case of unstable nucleus which emits radiations or particles in order to achieve the stable state. Is it? So now there is a word or say constant which is said to be decay constant. So the probability per unit time that a nucleus will decay is constant. Probability per unit time that a nucleus will decay is constant, and that is a decay constant. Or decay constant is nothing but it is the proportionality between the size of a population of radioactive atoms. Population means it is amount. It is the size of a population of radioactive atoms and the rate at which and the rate at which the population decreases because of radioactive decay. It's a constant, and that is said to be a decay constant. Okay, and it is expressed in terms of Curie or Rutherford. Expressed in terms of Curie or Rutherford. Say 1 Curie means it is the mass of the radioactive element. It is the mass of the radioactive element which produces 3.7 into 10 raised to 10 disintegrations per second. Or Rutherford, it is the mass of the radioactive element which produces 10 raised to 6 disintegrations per second. Okay, so with this now we'll move through say derivation of lambda. So imagine A is the radioactive element and after disintegration it gives B. Okay, so now let N0 be the initial amount of A taken, and that time B is not present, say it is 0. After time T, the N, it is the amount of A left undisintegrated. Amount of A left undisintegrated. And the amount of B formed is N0 by N. Okay, so now this is a first order kinetics. That means rate of disintegration is directly proportional to the amount left undisintegrated. That means minus dN by dt proportional to n, or minus dN by dt is equal to lambda n. So lambda is the decay constant, proportionality constant, or it is further said to be decay constant. Okay, or dN by n is equal to minus lambda dt. On integration, we get ln n is equal to minus lambda t plus c. C is the integration constant. Now suppose if time is equal to 0, if t is equal to 0, then n is equal to n0. Is it? When t is 0, then the n must be equal to n0. So the equation 1 becomes ln n0 is equal to 0 plus c, or c is equal to ln n0. And now the equation becomes, by putting this value in equation 1, becomes ln n is equal to minus lambda t plus ln n0. Or rearrange the terms and you will come, say here ln n minus ln n0 equal to minus lambda t. So this will be, say by removing this n, ln n by n0 is equal to minus lambda t, or reverse the terms, then it becomes plus ln n0 by n is equal to lambda t, or lambda is equal to 1 by t ln n0 by n. Or by taking the log, say lambda is equal to 2.303 by t log n0 by n. So this is the expression for lambda, or disintegration constant or decay constant. From this equation, where ln n by n0 is equal to minus lambda t, and even we can write this as n by n0 is equal to e raised to minus lambda t. Say this is the equation 4. Okay, so with this we'll move on to the next one, that is half-life period. Okay, half-life period, which is denoted by T half. Okay, so T half or half-life period. So it is nothing but it is the time required for the disintegration of one half of the original amount of the radioactive substance is said to be a half-life period. See here, half-life period. For example, A gives B. Okay. Now, suppose we have taken A 100 gram. 100 gram of A is taken, and when the A after disintegration decay, okay, it becomes 50 gram. Okay. So now the time taken to reduce, see the time taken. So for the decay process, so the time taken by the decay process to reduce the initial amount of a radioactive element to exactly half is said to be a T half. It is said to be a T half. Okay, that is half-life period of radioactive element. Is it? So now, or we can say it is the time taken to reduce the initial amount of a radioactive element to exactly half is nothing but is the half-life period. Okay, so now you are well familiar with the say decay constant expression, where it is lambda is equal to 2.303 by T log of n0 by n. Okay, so now now our aim is what? We have to get the expression for T half. Say when the time is equal to T half, that means half, and then say the n must be equal to n0 by 2, isn't it? Because n0 is the initial amount, and exactly to reduce it to half, that means n must be n0 by 2, whatever the time taken is equal to T half. So now putting that one here, say 2.303 by T half log of n0, and now n is equal to what here? Amount left is exactly half of the initial, so it is n0 by 2 and it's lambda. Okay, or it is nothing but 2.303, okay, by T half. It is log of, say reverse this one, n will get cancelled and it becomes log 2, or on simplification you will get it is, that means 2.303 into log of 2. Log of 2 is 0.3010, is it? So by T half. So this comes lambda is equal to 0.693 by T half. Okay, or T half is equal to 0.693 by lambda. So okay, this will be the expressions for half-life period of radioactive element. Okay, so with this we'll continue the next class by taking some problems. Thank you.